झालं ना. हॅलो.
हां
हा हे बघ मी ना इथे हे जे स्ट्रिंगला रिव्हर्स केलंय ना
हां
त्याच्यात हे पण मी एक्सप्लेन करतो म्हणजे ऍरे पॉइंटर टू ऍरे पण एक्सप्लेन करतोय म्हणजे फक्त थोडस एक्झाम्पल मध्ये एक्सप्लेन करेन मी
हां
त्यांना.
हां चालेल चालेल.
ठीक आहे.
ठीक आहे, मग मी स्टार्ट करतो
हा
आता. तू ह्याची पीपीटीची
स्टार्ट करतो का?
स्क्रीन, हां पीपीटीची
थांब
स्क्रीन घेऊन टाक.
मी पीपीटी ओपन करून ठेव ना.
हां
हा
स्लाईडवरती येऊन
ठीक आहे. प्रेझेंट करू मी?
नाही,
अच्छा
प्रेझेंट
हा
चालूच आहे ना तुझं हे. हां ते प्रेझेंट कर. जेव्हा तुला कोड करा असं वाटेल
ते
तेव्हा
प्रेझेंट
कोड
करतो.
करायला एडिटरमध्ये जाऊ शकतो, की त्याचं काही हे नाही होणार.
हा चालेल.
हां
हम्म.
या लोकांना लिंक पाठवतो थांब. ठीक आहे. Okay, so hello everyone. We will wait for 5 more minutes and then we will start with the session. So we will start exactly at 5:05. Okay. Okay, so it's 5 5, so we can start now. So in previous session, we as we studied, we completed our first linear data structure, which was stack data structure. And now in today's session, we are going to cover with pointers in C++, and also we will be starting with introduction of queue data structure. So today's pointer session will be taken by Vaibhav Korlikar. So over to you, Vaibhav. You can start.
Thank you, Aniket. We will start with the pointers in C++. Next slide. Hmm. So, what are pointers? Pointers are the special variables that are used to store addresses rather than values. C++ pointers are easy and fun to learn. Some C++ tasks are performed more easily with pointers, and other C++ tasks, such as the dynamic memory allocation, cannot be performed without them. So we can declare the pointers using data types like int, double, float, and character. Next, we are having null pointer. So why we required null pointer? There is no special requirement, but it is a always good practice to assign the null pointer to a pointer variable in case if you do not have exact address to be assigned. Okay, whenever the pointer is not in the use, we assign null to the pointer. So this is done at the time of a variable declaration. A pointer that is assigned null is called as a null pointer. You can see the program here how we assign the pointer to the null. Whenever the pointer is not in the use, we simply assign it to the null value. Next is our pointer to pointer. It is a very important topic in the data structures. A pointer to pointer is a form of a multiple indirection or a chain of a pointers. Normally, a pointer contains the address of a variable. It is very important. Normally, a pointer contains the address of a variable. When we define a pointer to a pointer, the first pointer contains the address, and the second pointer, which point to the location that contains the actual value as shown below. So we'll now understand this with few examples. Now I will go to my code editor. Okay, so we'll see what is a pointer to pointer. Okay, so now we are going to see what is a pointer to pointer. Aniket, my screen is visible.
Yes, it's visible. You continue.
Okay. Let me comment this out. So we are discussing pointer to pointer. So you can see here I have declared a variable a which stores a value 5. Now what we have to do, we have to learn pointer to pointer means there will be two pointer pointing to the same location, right? Now I will first take up one first pointer p. Now this pointer p, to point this pointer p to the variable a, what we have to do, we have to store the address of the variable a in a pointer p. Then it will point to that location. Now the P is storing the address of the A, means pointer P will store the value of the A. If I see out the statement which I said now, pointer P, it will store the value of the A. And L here, and L I want to write. Huh. You can see now we have a now we can see the pointer P is successfully pointing to the location A. Okay, so now what we have to do, we have to point another pointer on the same location. So for doing this, we have to as star star q. For pointing two pointers on the same location, we have to use two star. Okay, first pointer p is pointing to the a, then second pointer q will point to the a, but it will use double pointer. Okay, so what we want to achieve now, the pointer q, should store the value 5. So how we are going to do this? So for that, first the pointer q, which is second pointer, will first take the address of the first pointer, which is p, right? Our first pointer is p. Then uh, now q is storing the address of the p. Then pointer q should store the value of the p. And what is the value of the p? P is storing the address of a, variable a. You can see this, p is storing the address of a. Okay, so we'll print this statement. Pointer q, which is the second pointer, pointer q will store the address of a, right? So address of a is stored. I run the program and let's see, we'll get the we getting. So you can see the address of a is this. Now pointer q is storing the address of a. Means pointer q will store the value of the a. Means indirectly we are pointing to the same location using pointer to pointer, right? This is the topic which we want to learn. Okay. Now as the pointer q is storing the address of the a, then pointer q will store the value of the a, right? Pointer q will store the value of the a. Oh, I missed the semicolon. Hmm. Yes, for now what we have did initially, we have declared the variable a, and we have also learned the null pointer. We can apply this here. So whenever the pointer p is not in the use, we can mark it. We can assign it to null. Okay, it will doesn't affect our output. So we have declared the two pointers, pointer p and pointer q. Then initially the pointer p is not pointing to anywhere, so we have assigned it to null. Then to point the p variable to a, we have first stored the address of a in the variable p. Then we simply print the value of pointer p. Then we are to pointer q. Using this we have done. Okay, I hope you will you have understood this. So we'll move to the next. Okay, so now we'll discuss um, how to access the elements in array using pointers. So first what we have discussed about the null pointer, then we have discussed about the pointer to pointer. Now we are discussing about how to access the elements in array using pointer. So uh, here what I have taken an array which is of a which storing the element. Now if I want to print uh, in the earlier sessions what we have studied how we print the elements in the array, we know the variable name just by using the index number of the array. We know array starts with a 0, so using the index number of the array we can print. Okay, we have this simple method, but why we need to study pointers? We can still assign the print the elements using pointer. So if I have to print the first how we print using pointers, the variable a of the array, the variable of the array stores the base address of the variable stores the base address of the array. Okay, if I print the a, it will store the base address of the array. Okay, so if I print the a, this is the base address of the first element. Okay, This is the base address of the first element. But if I print the pointer A, then it will print 10. Pointer A means a value of the base value at the base in the base address. Okay. A will print the base address and pointer A will print the value in the base address. If I want to print A to element 20, what I will do, what usually we do, A square bracket 1. So it will print 20, right? But instead of this, we can also use pointers. Uh, we write pointer in this way. Whatever the variable present before the bracket and inside the bracket get added. Okay, remember this. Whatever the variable present before the bracket and inside the bracket will always get added. Now to print using the to access the elements using the pointer, what we'll do, will first you write the asterisk sign, then base address of the array plus at which position you want to print. So you want to print uh, 20, right? So a plus 1, a is storing the address of this location. So a plus 1 will store the address of this location, and pointer means we want to print the address of this location. Okay. So a plus 1 is the address of 20th element, and pointer a plus 1 is the value of this uh, ith index. Okay. So you will get again 20 in the output. I have one more question for you. If I declare index int I is equal to 3, okay, and I am want to print cout a of I, right? What will be the output? It will be 30, right? Everybody knows this. We have covered in the previous sessions. A index I is 30. Sorry, 40. हाँ, 0 से start होता है ना, तो 40. So, but if I write this way, then what will be the output? Is this correct or it has some error? No, it don't have any error. It is right. What happens is it will give still same output. You can see it has compiled successfully, finished, and output is R still 40. So why there is no error? Because whatever is present inside the bracket and before the bracket and inside the bracket gets added, right? So when suppose if you write address of this, then you will get the address of the 40th element. Okay, ith element, right? Now you what is this, right? Whenever you want to access the element, it adds both the elements, means whatever the element present before the bracket is added with the element present after the bracket. As there is no address sign, so it will assume as a pointer. Okay, this is the way it will print. If I uh, see out this statement, then it should run. So still you are getting the output as 40. Okay. So this way we can access the elements using pointers. All right. I hope you have understood this. There is no doubt. If you have any doubt, you can write in the live session. So yes, Aniket, you can start next. Next is the queue.
Okay.
Hmm.
Okay, so I hope everyone would have
Should I
understood
stop?
what Vaibhav had.
Okay.
Yes, you can stop the sharing and you can also end the meet if you want. Okay.
Okay.
So why we studied these pointers? Because they are important in our next data structures which we are going to study, which are queue and linked list. Without pointers we will not be able to understand what is happening in queue and linked list data structure. So pointers is really very important topic for that, and it is pretty easy topic, but some of you find it hard, so we have made it easy. Also we will be showing one sample problem on pointers which Vaibhav will show at the last of this session. So firstly let's get with the queue data structure. So today we are just going to discuss the introduction of the queue. So what is queue data structure? As we studied previously, we have studied array and stack data structures. So array was simply a linear data structure which is having certain elements of same type. Then stack was a data structures which also contains some elements just like array, but it has a special property like you cannot insert new elements from bottom of it. The bottom is closed and you can only insert and delete from the top of the stack. So it was a LIFO data structure, last in first out, क्योंकि जो लास्ट में एलिमेंट हम लोग डालेंगे वही स्टैक में फर्स्ट बाहर निकलेगा. So that's why it's called LIFO. Now coming to queue data structure, just like stack, queue is also an abstract data type. As the name suggests, in queue the elements are inserted at one end and deletion takes place at other end. So you might have heard about queues of people, just like this. Suppose there is a queue at the movie counter. So in queue we can see people are standing one behind another. So when the first suppose this is the first person was only there and these four were not there. So when he enters, first he will get the ticket and he will move on. Then second person will enter, he will get the ticket and he will be moved out. So in this way, in queue, insertion and deletion are taking place from different ends. It is not like that ki this is the first one and he will get the ticket and he will be removed from this side only. This is the first one, he will move till here, then he will get ticket and then he will be moved out of the queue. So in this way queue data structure follows first in first out operation, which is called as FIFO operation. So this is the main principle of queue data structure. Now nextly we can we have multiple operations which we carry out on our queue. So those are enqueue, dequeue, peek, is full and is empty. So let's study them one by one. So queue operations involve initializing or defining the queue, then utilizing it, then how to erase the memory, how to create a new element, how to insert it inside queue. So all of these operations. So first is enqueue. Enqueue means simply insertion. In queue it is called as enqueue. So it means that to add an element into the queue. Next is dequeue. Dequeue simply means deletion or it is removal of an item from the queue. So these two are important operations. Next is we have other operations which are peek. Peek gives us the element at front of the queue. So firstly we should understand what is front of the queue. Front means the person who was standing in the at the ticket counter, he was the front of the queue. So that is called as the front. Next is full. This function checks whether the queue is full, and if the queue is full then it will give you true or false. Next is empty. So if the queue is empty we will get true value. Now let's understand what are the pointers which we are going to use in our queue. So as you can see here, it is showing dequeue operation. So for enqueue operation, which is insertion, what we have to do, we have to set two pointers, front and rear, which are pointing at the 0th element. Then we move rear one by one and the elements are getting added. For deletion we move the front pointer and the elements are getting removed out. In this way enqueue and dequeue operations are going to be performed inside queue. We will study them in detail once we get with the coding part and how exactly the mathematics and calculations we are going to do on them, how we are going to set the front and rear pointer. So that part we will study. This is just for introduction. So in this way, as you can see, whenever you insert element, the rear pointer is getting incremented, and for deletion the front is getting incremented and the elements are deleted. In this way the insertion and deletion, which are enqueue and dequeue operations, are handled. Now let's see what are different types of queues. So we have first simple queue, which is linear queue, which we saw just now. Next we have a type of queue called as circular queue, priority queue and doubly ended queue. So what is simple queue? In a simple queue, insertion takes place at the rear and removal occurs at the front. Okay. So if this is front part and this is rear part, so insertion, if you want to insert new element, it is going to be performed at the rear end, and deletion is going to be performed at the front end. So this direction of arrows don't go on them. Just to know that these three persons are standing, then new person will be inserted from this side, then deleted, the first person who was at the front will be deleted from this side. In this way simple queue operation is performed and it follows FIFO operation only. Next is circular queue. In a circular queue, the last element points to the first element, making a circular link. So just we have to point the last, which is the rear part, to the front part. So in this way the rear part is connected to the front part of the queue and a circular queue is formed. Next is priority queue. Priority queue is a special type of queue where every element has certain priority, and according to that priority the elements are kept in the queue. If same priority elements are there, then accordingly we have to serve certain order in the queue. So in this way the priority queue work. We will study it when we will complete the previous two queues. Then we will go into deep part of programming the priority queue and understanding how it works. Next is double ended queue, or we can say DEQUE. So it is DQ, double ended queue. So in a double ended queue, insertion and removal of elements can be performed from either the front or the rear. So दोनों side से भी कर सकते हैं. Thus it does not follow FIFO order. So FIFO order is not followed here. So insertion and deletion can be performed from the front side also and from deletion rear side also. So if this is front and this is rear, and if this was a simple queue, we can only, from the front part we can only do DQ or delete operation, and from the rear part we can do insertion operation. So in doubly ended queue we have different set of rules. Now let's understand why we are studying this queue data structure. What are the applications of studying it? So in the real world we have many applications such as CPU disk scheduling. Then when the data is transferred asynchronously between two processes, for example IO buffers, then the files in your system or pipes. So all these are internal computer operations for which the queue data structure is being used. Like you might have heard of disk scheduling, CPU scheduling, where we have to schedule the task of the CPU one by one, and those are ordered in a way of a queue by using queue. Next is handling of interrupts in real-time systems. So certain interrupts which are or the errors which occur in our compiler or in the computer, those are also handled by help of queue data structure. Next, another amazing example is call center phone system uses queue to hold people in order of their calling. So they make queues of the people who are calling them, and then one by one they make the orders or take the phone calls. So these were all things about queue. Now the coding part and how we are going to move the front and rear pointer, and what is the actual enqueue operation, how we can code it in C++. We will study that in the next session. So for this session we just are going to stop here with the basic introduction of queue. So over to you, Weber. Now you can share the problem which we are going to discuss.
At the end of the session now, we are going to take one problem on pointers. Reverse the string using pointers. So
Weber,
let's go to
you
the
share
code
the screen.
editor.
Okay, it's visible
Screen
now.
is not visible.
Yes, it's visible. You continue now.
Huh. So so I told you our problem statement is we are given a string and we have to reverse the string using pointers. Okay. So how we are going to access the elements inside the string using pointers. So it is important to understand. We are given a string. Okay. This string is stored in a pointer character pointer which is a character data type. Okay. The string is stored in the str, which is a pointer of character data type. Now After we are printing in this second line, then to access the elements in the string, we are taking a for loop. Inside the for loop, first we are finding the length of the string. It is very important. Otherwise, how will you print the string, right? So first you have to get the length of the string using strlen function. Uh, then first we get the length of the string and we decrement it till the zero. Then how the pointer comes in the picture is we are printing it rather than using array, we are printing it using the pointers. So here we are uh, printing the last element of the array first, right? Last element of the string first. How it is printed? Str. What the str store? Str will store the base address of the string. What is the base address? Base address of the string starts with this capital C, right? Capital C. You know the capital C is stores the first index value, then it is second index value. So the base address starts with this. Okay, and as we add the ith element in this, uh, the cursor will come here and it will print the last element. Base address is added with the last length of the array. Okay, so it will print. I will run and show you the output how it is been taking. You can see we are given the string and we have reversed the string. Okay, and what if I we can also do it like this. Str I. This will also run. Okay, this will also give the correct output. But the point is that the pointer comes in the picture because both the things are same. Whether we are writing str of I or at the end of the thing, whenever it is decoding the statement, it decodes like whatever comes before the bracket and after inside the bracket. It adds them and convert it into the pointers. Okay, at the end of the code, it is going to run with the pointers only. So this is the application of the pointer to pointers we have learned. Okay, pointers using arrays. So this is the code. You can see. If anyone has any doubt, can write down below. Anything else?
Okay,
So
so
we are done with our
yeah.
session today.
So thank you
If
everyone for
anyone
the
has any
session.
doubt,
Yeah, if anyone has doubt, you can ask here, or you can also ask on the CodeChef group, the Miss and Place group, which we have
yes.
created on WhatsApp. And also we are providing you materials and resources for this. So make sure you are going through it and you are solving the questions which on time, which we are sharing. So it is because it is really helpful for the interviews and all your coding rounds. So we will stop here with today's day 5 session. In the next session we will
Okay.
continue with the Q data structure. Okay, so till then, take care. Goodbye.
Bye. I will stop the sharing.